The instruction is the same. Sketch the graph and determine all the elements, amplitude, period, average y-value, domain range, and the coordinates of the endpoints. Okay, so my new equation, y is equal to 5 cosine of 3 over 2x plus 4. Remember that having the 4 at the end of the equation, adding, means that you're going to have a vertical movement, and these 4 can also be written at the beginning of the equation. Positive 4, it's exactly the same at the beginning or at the end. In both cases, which is the same case, it's positive, so that means that the graph is going to be shifted up 4 units. Okay, so let's begin with this. Our amplitude in this case, let's remember from the previous video that the amplitude is the coefficient of the function. In this case, it's cosine. So its coefficient is 5, the amplitude is going to be 5. Let's remember also that the p is the coefficient of the x variable that is inside of the parentheses. So in this case, the coefficient is 3 over 2. So this means that b is equal to 3 over 2. If I want to get my period, what I will have to do is 2 pi over 3 over 2. So this means that I will have 4 pi over 3, and that's going to be my period. My period is 4 pi over 3. My average y-value, since the graph is shifted 4 units up, that means that the average y-value of the original function, which was at the x-axis, is now going to be shifted 4 units up from the x-axis. Remember that I have to get that, and the average y-value is going to end up being at y is equal to positive 4. That would be the equation of the average y-value. Sorry, I ran out of space here. So my average y-value is y is equal to positive 4. That means that I'm going to trace a line on the coordinate plane, and y is equal to positive 4. Now the endpoints. Let's remember that I am enclosing everything inside of a box. So I go to the endpoints. Remember that this part of the equation, 3 over 2x, which is inside of the parentheses, is going to be giving me the endpoints, at least the x-coordinate of the endpoints over here. So in this case, let's go back to the equation. This equation is telling me an amplitude of 5, a b of 3 over 2, which gives me a period of 4 pi over 3. The graph is shifted 4 units up, and since I don't have anything adding or subtracting to the x, the graph is not going to have a horizontal movement. So when I am getting the endpoints, this part that I am missing over here is a plus 0. So I write it as a plus 0. There is no plus c here, so it is plus 0. I consider it as a plus 0, or just don't write it down. Doesn't matter. So if I want to solve for x, for the endpoints, what I'm going to be doing is the 2 will pass multiplying, 0 times 2, 0, and then the 3 is going to go dividing. So my endpoint, the first x coordinate, the first x of the coordinate is 0, and for the other part, I'm going to do the same, 3x over 2 plus 0. So it's equal to 2 pi. I solve for x, passing the 2 multiplying, so it's 2 pi times 2, 4 pi, and the 3 will go dividing. Sorry, I wrote 4 here, but it's a 3. X is equal to 4 pi over 3 in this case. Okay, so those are my 2 x values of the endpoints. Remember that later on I will have to translate this into coordinates. So the coordinates will be 0 comma something and 4 pi over 3 comma something. Sorry, I made a mistake there. Okay, so let's see how this is going to translate in my coordinate plane. Remember that I'm going to get the box, so I go 0, which is my y-axis. That would be the first limit of my graph, and my graph will have to end at 4 pi over 3. So my graph is ending right there. If you notice, look at how I split the x values over here. If my period is 4 pi over 3 and my endpoints go from 0 to 4 pi over 3, then that means that I will have to split this into 4 equal parts. This one that says pi, I have 1 pi over 3, 2 pi over 3. This is obviously 3 pi over 3, which if I simplify is pi, and then I end up at 4 pi over 3. It's one way of splitting the periods. The period in 4 whenever you have fractions, okay? Use the denominator to split that into different parts. So my average y value shifted 4 units up and my amplitude is 5. So that means that my upper part is going to end up at 9. I go, remember, 5 units up above the average y value, which is a measurement of the amplitude, and 5 units below the average y value, which is the amplitude in this case. So I am there. Remember that I am working with a cosine function, so that means that my graph is going to be U-shaped. Okay, so this means that according to this, the graph is going to begin in the upper left corner. My graph is going to be beginning in the upper left corner over here. In the first quarter, it's going to cross the average y value. In the second quarter, it's going to reach its minimum. The second quarter is half the period. On the third quarter, it goes back all the way up again to the average y value, and then to the upper right corner of the box. And the graph that I am looking for is going to look something like that. Remember, it's U-shaped because I am working with a cosine function. Okay, so this means that my actual endpoints 0, 9, and 4 pi over 3, which is this part, is also at a height of 9 in y. Okay, so now the domain and the range, their domain goes from 0 to 4 pi over 3. And the range goes from -1, the range goes from -1 to +9. And that is a complete problem. Okay, as you notice, there are 2 more problems that are telling you to try this, to try to do them. So go ahead, I'm gonna give you a few minutes to try to work. The first one was y is equal to -3 plus sine of 4x plus 2 pi. Obviously, this graph is going to be having a vertical movement downward. Remember, this can be written at the beginning or at the end of the function. The coefficient of sine is 1. There's no number there, so the coefficient is 1. Therefore, the amplitude is 1. The amplitude of this graph is going to be 1. Okay, then we go to the b part. The b is 4 right here. B is equal to 4, so that means that the period is 2 pi over 4, which is pi over 2 if I simplify 2 over 4. So my period is pi over 2. Now I have plus 2 pi in this part. This means that the graph is going to be shifted 2 pi units. I'm sorry, it's going to be shifted to the left. We will figure out how many units after I get the endpoints, okay? Because I have a coefficient in front of the x. So it is shifted to the left because this is positive. So I go and get the endpoints. Bx plus c is equal to 0, which is this part of the equation, equal to 0, solve for x. So x is equal to -pi over 2. This part over here is going to be telling me the phase shift. Remember that I told you that we were going to discuss the phase shift of the graph. The phase shift is the horizontal movement of the graph. I cannot obtain it directly from this part over here just by looking at the graph. This one will only tell me direction. I have to solve for x whenever, because I have a coefficient here, so that coefficient is going to be affecting my horizontal movement. So the phase shift is pi over 2, or a horizontal movement of -pi over 2 or pi over 2 units to the left. Okay, it can be determined in any way, which is my first endpoint. Then I get the second x value of the endpoints, the second endpoint. So bx plus c or minus c, doesn't matter, the sign doesn't matter, is equal to 2 pi. So from there, remember that I don't change the signs of these ones in order to solve it. 4x plus 2 pi is equal to 2 pi, I solve for x, and the other one is 0. So my graph in x is going to be going from -2 pi to 0, which is actually my domain. Okay, and if you notice, I enclose that area in the graph. Now, for the scale of the graph, pay attention to this one. I have fractions, obviously. I determine that my graph is going from -pi over 2 to 0. Obviously, half the period is going to be at -pi over 4. Half divided by 2 is 1/4. And then I split that in half again. So this one, pi over 2, Actually, the denominator is 8, and in this one is also 8, but it's already simplified. So if you notice, I have minus 3 pi over 8, minus 2 pi over 8, minus 1 pi over 8, minus 4 pi over 8, which is giving me these simplified fractions. That's an easy way of having your period or your horizontal extension divided into 4 equal parts whenever you have fractions. And notice that on this side of the y-axis, at the positive side, I am beginning at pi over 8. So the next one would be 2 pi over 8, which would be pi over 4, and so on. Okay, I hope you got this information, and if not, review fractions somewhere else. Okay, so I have my box from negative pi over 2 to 0, okay, which is what they were telling me with the endpoints, the x values of the endpoints over here. Negative pi over 2 to 0, that's the extension of the graph. The average y value, the graph is shifted 3 units down. So from the x-axis, I am going 3 units down, which is going to be the middle part of the graph. So 1, 2, 3, here I have my average y value, okay? And from there, my amplitude was 1 because there was no coefficient in the sign. So I go 1 unit up and 1 unit below the new average y value, the one that was shifted downward due to the original equation. And from there, since I have a sine function, remember that the sine functions begin exactly at the average y value. So this would be the graph that I'm going to be getting, splitting the graph into 4 quarters. You just have to remember which shape each function has, and this would be the shape of this sine function. I hope that it is clear and that you got a correct answer. If not, we can discuss questions in a little while. Okay? The second problem. For the second problem that I gave you as a try this, it was y is equal to 3 cosine of 3 over 2x minus pi plus 2. To begin with, my amplitude is 3, which is the coefficient of the function. B is 3 over 2, and the graph is shifted to the right. Remember that I cannot tell the units that the graph shifts from the parentheses. I have to get the endpoints to determine that. So the only thing that I know is that the graph is shifted to the right and 2 units up. Okay, these are all the translations that my graph is having. So my amplitude is 3, B is 3 over 2, my period is 2 pi divided by 3 over 2, which is 4 pi over 3. That is my complete period. And the average y value is y is equal to 2 because the graph is shifted 2 units up. Remember, the original graph has the average y value at the x-axis. So that is why I am shifting 2 units up, and that's how I get the average y value with the vertical movement. So from there, I go and get the endpoints. Bx minus c, again, this one can be positive or negative, it doesn't matter. I just take it directly from the equation. 3 over 2x minus pi is equal to 0, and 3 over 2x minus pi is equal to 2 pi. Solve for x, so the first x value is 2 pi over 3, and the ending of the graph is 2 pi. Okay, so in my endpoints, 2 pi over 3 and 2 pi. Remember, I just get the x values here. The y values are going to be obtained from the graph. So in my graph, having all of this information, my average y value shifted 2 units up, it's at y is equal to 2. Then the endpoints, 2 pi over 3, all the way up to 2 pi. Notice how I am splitting the x-axis. I begin at 2 pi over 3. That means that everything is going to be divided into 3's. My fractions will have denominators 3. So I will begin 1 pi over 3, 2 pi over 3, 3 pi over 3, that is pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, that is 2 pi. And the same will happen to the other side of the y-axis. I hope that we're clear on this again. So I have to split my period in 4. 1, 2, 3, and 4. Okay, since it is a cosine function, it is going to be U-shaped. The graph is U-shaped with an amplitude of 1, 2, 3, which is the coefficient of the function, above and below the average y value. So this is the shape of the graph, upper left corner, first quarter, lowest point at half the period, third quarter, and the upper right corner is going to be the ending of the graph. So the domain and the range, the domain goes from 2 pi over 3 to 2 pi, and the range goes from -1 to 5. And there's a complete solution for the try.